Welcome to Maths and Science by IITian channel. In this lecture, today I will be taking up a very good example on prime number to test whether a number is a prime number or not. I will explain about a simple easy way so that any number of digits you can easily tell whether it is a prime number or not, but it requires a little bit of logic and also hard work. And in this we use different rules which I have explained in my previous two short videos I have given about the divisors from 1 to 10 and also 11 to 20. 1 to 10 divisors and 11 to 20. What are the conditions under which a given number is divisible by these numbers, for all these 20 numbers? Once we know this, for 3 digits, 4 digits, 5 digits, it will be easier for us to find out the prime number. Now, finding the prime number, it's a 4-digit number, it will be easier. Even a 5-digit number also will be easier. As you practice more and more problems, it will be easier. It will be more and more easy for you to know whether a particular number is prime number or not. We will be using the section rule. In addition to that, section rule tells us whether it is probable that this particular number is a prime number or not. Probability. It will not correctly tell. At least it will give a direction to us. It can be a prime number or it cannot be a prime number. For example, 8431 when divided by 6, it gives a remainder as 1. That means there is a probability that this number can be a prime. Then we can proceed further to find out whether it is a prime or not. Whereas 8437 when divided by 6, what happens? It gives a when divided by 6, what happens? 8437, it gives a remainder as 7. That means it clearly says that this particular 8437 is not a prime number. Are you able to understand? By section rule, we can at least find out what is not a prime number. And from the section rule, at least we can say that this particular number can be a prime number, so that we can apply the other rules. We will explain these rules now. Question is to know whether 8431 is prime. First step, what we have to do in the solution? Find whether remainder when divided by 6 is either 1 or 5. Here 8431 by 6 gives 1 as a remainder. It implies this number can be a prime number. Not 100% sure. Probably a prime number. Instead of can be, we can even write probably a prime number. Probably a prime number. Now what are the other rules? Now we will proceed for other rules. First rule is it's not odd. It's not even. Sorry, it's not even. That implies not divisible by 2 and multiples of 2. That means like that we have removed many numbers. Next. What is the next step? For the number to be divisible by 3, sum of the digits should be divisible by 3. Sum of the digits is equal to 8 plus 4 plus 3 plus 1, that is equal to 16. That is not divisible by 3. Hence it is not divisible by 3. Next condition, you can see my short video, number rules. Short video, number rules 1 and number rules 2 for up to 20, 1 to 20. Details given. You please refer to that. And even numbers, it's not divisible because it is not divisible by 2 because it's an odd number. Then what we have to see? For 5. Some last digit is not 5 or 0. That implies not divisible by 5. Six, it is not divisible. Next, 7. For 7, whether it is to be divisible or not, you see, treat it as a homework, do it, check for 7. As per rule, you check. It is not divisible. Next, 8, it is not divisible. 9, sum of the digits is equal to 16. That means not divisible by 9. Then sum of the alternate digits is 8431. 8 minus 4 plus 3 minus 1. 4 plus 3 6. Not divisible by 11. 12 we need not see. 13. That you treat it as homework. 13 divisibility. 17 divisibility. Please refer to my shorts video. Not divisible. All these you just see and check. At least why I give so that mathematics can be understood only by doing it, not by seeing or not by listening. And ultimately another final solution is like this. Check for square root of 8431. What is the square root of 8431? 91.820. That is approximately equal to 91. Up to 91, you check the divisibility. If by any number below 91 it is divisible, then it is divisible, otherwise it is not, it is a prime. What are those prime numbers you have to see? Prime numbers up to 91 is equal to, prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, up to this we have done. 23, 29. Now prime numbers are at a farther distance from each other. You just see. Not as very close as when they are in single digit. "53, 59, 61, 67, 71, 73, 79, 83, 89. I told you many times, please try to read them number of times so that at an intuition you will get an answer within 100. What are the probable? What are the prime numbers? Please remember them. If you don't remember, at least up to 20 you remember. Then for example 89 I want to know whether it is a prime number or not. What I have to do? At least up to 20. 1, 2, 3, 4, 5, 6, 7, 8. 8 tests if I can do them, then I will get the answer. At least up to 20, because others are some repetitions like 89. What is the square root? Square root of 89 is equal to approximately 9. 9.4. That means up to 9. If you calculate or check for primality, then we can know about 89. This 20 whatever are there, if you can remember, at least up to 20. 1, 2, 3, 4, 5, 6, 7, 8. Up to this number if you remember, then square root of 400 is equal to 20. That means up to 400 numbers you can find out whether a particular number is prime number or not. For example, if I want to know square root of 397, whether it is a prime number or not, I want you to understand the concept. This is 19.924. That implies up to 19 I have to check to find out whether 397. 397 divided by 2, it's not possible. 397 divided by 3, is it possible? Just check. 397 divided by 3. It's not divisible. Divided by 5, not divisible because last digit is not 5 or 0. Divisible by 7. Apply the rule. It is not divisible. Divisible by 8. No, 8 is not required because with 2 it is not divisible, means 8 is also not divisible. 11 divisible by 11. 397 divided by 11. You see whether it is divisible. It is not divisible. 397 by 13. Very simple. How fast you are able to do? Just see. It is not divisible. 397 by 17. It is not divisible. 397 by 19. It is not divisible. This is an examples I give so that you understand the concept. 397 is not divisible by any prime up to 19, which means it is a prime. Here also for 8431, for the given 8431, given number 8431, square root of 8431 is equal to 91. Up to 91 we have written our what you call primes. 90 is not a prime, 91 is not a prime. Up to 89. And we are able to check up to 19. The 23, 29, 31, 37 also. For remaining divisions by primes 23 to 89. Treat it as homework and do it. Finally, final answer is that 8431 is a prime not divisible by any number other than number itself and 1. How we have come to this conclusion? One is that 8431 gives a remainder of 1 when divided by 6. That gives an answer that probably, it is probably a prime number, not confirm only. It can be a prime. Second step, checked for square root. Or not checked even, let us say calculated the prime square root. Calculated square root. That is equal to 91 point something, 6 or something. or else it can be 91.9. We got 91.8. Next step is listed all primes up to 91. Divided given number by each prime up to 91. Found that none could divide 8431. Then it implies 8431 is a prime. There are other tests also you can do. That also I have explained on many occasions in many videos. Please refer to them for other tests. It is one of the tests I thought let me explain you with an example so that you will appreciate it. Other tests for primality discussed in other videos from my channel. Ultimately 8431 is a prime number. That's what we could come out. We could finally decide. Now with this I want to close this lecture. If there is a value addition to you because of this lecture, kindly share my videos and my channel to others and subscribe to my channel. Maths and Science by IITian. And with this, from next class, we will try to do some actual Olympiad questions. And Olympiad like questions we will do. And after some few lectures, we will move to algebra. From number theory, we will move to algebra and functions. Best of luck to everybody. Thank you for listening to me.